All right, we are going to pick up with buffers now. So let's introduce this idea in chapter 10. What is a buffer? And we have the definition of a buffer on it's the first thing on the slide. It says it's a combination of substances in a solution that, here's the important part, act together to, I'm going to circle this word, resist changes in pH. So what does that mean if we're going to resist changes in pH? Well, what types of things can change pH? Okay, acids. What can an acid do to pH? Acids lower pH. How in the world do they do that? Acids generate, well, let me erase. Acids generate H+. They increase the concentration of H+. Okay? Because acids give away an H+. And the more H+ you have, the lower pH. What else can change pH? Bases. How can a base change pH? A base can raise pH by decreasing the concentration of H+ in solution. Bases accept H+. They scoop them up out of solution and react with them to neutralize them, and that's how we can raise pH, by removing, bases remove H+ from solution. Acids generate H+ in solution, bases react with them or remove them, and a buffer is going to resist changes in pH that can be caused by acids or bases. Okay, so a buffer works to maintain pH at its original value. Now, why is that important? Okay, the first statement down here, right below this, says it's crucial to maintain a proper pH in a biological system. So the problem we just worked regarding blood pH, we saw that if our blood pH drops to even a value of 6.9, we could fall into a coma. So it's crucial that our body maintain our blood pH. And it's also, we use research. Okay, the things we've learned about the body is built on the shoulders of tons and tons and tons of research. And if we are going to model things in the body on a laboratory bench outside of the body, we need to be working in solutions that have a pH equal to what our biological system has. Okay, so if we're trying to model something that's going on in a rat or a mouse or a human, or whatever animal we're studying, or any sort of biological system, we need to work in solutions that contain the same pH. So we have to work with buffers. A lot of times we use buffers to maintain pH in laboratory solutions as we go about doing research on biological systems. So those are two reasons that this is really important. Here's what a buffer contains, because we said it's a combination of substances, right, up here in that first statement. Well, what kind of substances? A buffer is usually, I don't know why we put usually, it's always, pretty much, a weak acid and its conjugate base. Okay, that's what a buffer is. A good buffer, at least. So, remember when we talked about Ka and we introduced equilibrium for weak acids, we can write the dissociation reaction for a weak acid. Ha plus water, we get a double arrow here. This indicates that we have an equilibrium, a reversible reaction, and we make the hydronium. If a hydronium ion, because water, if it's acting like the base here, water is going to grab up this proton off the weak acid. That's what makes H3O+. And then what's left over from the weak acid, when it gets rid of hydrogen, all we have is A- left over, the rest of the acid. Okay, that is the conjugate base. And the two components that are important here, we'll circle them in blue, are the conjugate base and the weak acid. These are the two components that are important to have in your buffer. Here's a very real example. We have acetic acid. You guys are learning how common of a weak acid acetic acid is. We use it for example, as examples in a lot of stuff. And here's the conjugate base of acetic acid, which is the acetate anion. And this is very common. Okay, if we had a buffer system that was like, for example, HF, what would be the conjugate base? This is an acid. Conjugate base would be F-. All right, so on and so forth. So anyways, I'm going to draw out another thing that I can consider to be very important. You're not going to be given this diagram on the exam. You need to know what I'm calling the buffer diagram right here. And it's going to teach us how buffers do what we just said, how they maintain a proper pH, how they resist changes in pH. So you need to memorize, you need to be able to draw out, you need to know this buffer diagram. So if we have a weak acid, and remember, we abbreviate weak acids HA. I'm going to just draw HA right here. So there's our weak acid. And let's say that we have a buffer system and we add a base. Remember, what can bases do? Right up here, we wrote that bases can do what? They can threaten to raise pH, okay? Well, we don't want the pH to raise. We want the pH to stay the same. But if we add some base, a very good example of a strong base is OH minus, right? What can this buffer system do to react with OH minus and neutralize it so that it does not drop pH? Or raise pH. Well, the weak acid right here, HA, has a hydrogen ion that it is willing to donate. So that's what it's going to do. This OH minus is going to scoop up this hydrogen ion right here. And when we do that, when we take this hydrogen ion, we react it with OH minus, they are going to make H2O. Will H2O affect pH? No, it won't. It's neutral, okay? So what we just did is we took this base, and it could lower, it's threatening to lower pH, but we reacted it with our weak acid from our buffer. We gave it the hydrogen ion from the weak acid, and we created a substance that will not affect pH, water. Now, what's left over from the acid? Every time one molecule of weak acid donates a hydrogen, what's left over is the conjugate base, a molecule of conjugate base. Okay? This is the conjugate base. So that is how a buffer would respond to the addition of a base to solution. Okay? Now let's play out the other scenario. Besides adding a base, the only other thing that could change pH, what we mentioned up here, is an acid. Okay? We said acids can lower pH. So if we add some acid, we'll start in this other corner down here, such as HCl. HCl is a really strong acid. How would the buffer system, this is essentially our buffer system. We know we have a reversible reaction right here between the conjugate base and the weak acid. So this is the buffer system right here. Weak acid, conjugate base. And if we're going to add acid, what is the buffer going to do to neutralize this? Well, this acid, HCl, we know it's going to disassociate. It's going to disassociate into H plus and Cl minus. That's just what acids do. And this guy right here, H plus, could drop pH if we don't do anything about it. So what part of our buffer system could react with this H plus to create something that is not going to change pH? And this is where the conjugate base steps in. So the conjugate base is going to scoop up that H plus, all right, and it's going to create more of the weak acid, okay? Now the weak acid, H is H combined with A. And this is not going to affect pH. The only time acids affect pH are when they dissociate. The non-dissociated form, this is the non-dissociated form of the acid does not affect pH, only the dissociated form, all right? So the parts that you need to know, this is the diagram that you need to know. All